Let's start looking at handrail assemblies. So I know all I showed you so far was a guardrail. The only difference between a more complex handrail assembly and the guardrail mass that I showed you is that you just break it down using DivideDomain squared and ConstructDomain. That's it, right? You guys are kind of starting to sense now that it's pretty much the same stuff again and again and again, but in slightly different ways. So what I have here is the line that was that we originally selected, right? So imagine that the whole definition is happening above this, and I just isolate this one in order to work on that line again. Doesn't matter if it's curved, doesn't matter if it's flat. Well, I mean, some things might, but generally speaking, all we need to do here is go to Freeform, Extrude, and we're going to extrude this line upward. So in order to, because this is a physical based operation and it's always going to go up, I can just use unit Z for this one. So I'm going to put in unit Z, and then I'm going to put in my magnitude. Now, handrails and guardrails are very specific to like building codes and stuff. So they're pretty much based off of inch values. So in the interest of being accurate so that you see a degree of care about that sort of thing, I'm going to actually transition this into inches. So I'm going to say 0 to say 48 at a maximum. And then because I want this to convert to inches, but I'm working in feet, I need to divide it by 12. So that's math. I'm going to put this at 42. And I'm going to divide that by 12. Now, why did I do 48 when I know I'm only going to need 42? I just do stuff like that in order to give myself some flexibility so I don't have to remake it or change it later if I need to design a little higher. Okay, so you plug that in and you get the actual guardrail. Now, this isn't too different from what you did before. I used Extrude for this one because it just extruded it straight up. You could use offset curve. But sometimes if you have either a tilting curve or a curve that's at an arc, like over a bridge, you're actually going to get the ends of your wall are going to tilt outward. So anyway, there are just a few little nuances there. But so here's the key. The bridge surface itself is really just going to be a series of subdivisions, right? So if I need to panelize it, the first thing I need to do is just subdivide it using DivideDomain squared. And this is that trinity that I mentioned before, the magic triangle, where you just use divide or isotrim and subsurface, and you plug them in like this, right? And that's going to start your subdivisions. But you're not done because you want to change the number of them. So I'm going to say 0 to 25. I don't know what scale your model is or how many subdivisions you're going to need, but that's probably a good place to start. Plug them in, and I'm going to change my U count to a little bit more, my V count to a little bit more. What I find is my U count is actually the vertical or the horizontal subdivisions. So if all I want is just one panel in height going all the way across, then I change my U count to 1. Okay. And then from there, I can increase my V count to be however many subdivisions I want. If you care about that, usually a general good rule of thumb is that you only want them to be 4 feet maximum. You know, it's kind of a rule of thumb, but it doesn't really matter that much while you're in school, only sometimes. But anyway, so from there, we have these subdivided surfaces. You kind of get where we're going with this? Well, handrails frequently don't go all the way to the ground. Sometimes they do, sometimes they don't. But if I wanted to raise that, then all I would need to do is take my original surface from my extrude, and I could ConstructDomain and just pull it off the bottom, right? You guys are kind of sense what that does. Anyway, so Subsurf right here, what I'm going to do to show you the simplest form of creating an assembly for it, right? We're just going to make pipes, right? Every vertical rail, every top rail, that's just going to be a pipe for this purpose. So I need to go to Surface Analysis and deconstruct BREP, right? Construct geometry, deconstruct geometry, construct new geometry. That's the whole name of the game. So from that, I can go to pipe, plug in all of my edges, and what you're going to see is as I type in something that's actually going to work for me, 0 to 2.0, as long as you turn everything off, you're going to get rails. Yeah, the edge doesn't cross. You know, rail is pretty limited, right? Because what's going to happen is you're going to have to change your cat, and the only one that's going to make a smooth edge is a rounded cat, and that's not really what it looks like in reality. But for a simple, very schematic model, it works. But let's put a value of 2 on the E input, and that's going to change it to a round cat at the edge. It's not perfect, but it gets the idea, you know, across. Especially if you're only viewing it from like this far away in your rendering, no one's ever going to tell. You know, that's the key about this kind of stuff, guys. Is you need to, once you start mastering the software, you need to start balancing how much time you're spending on certain things with what you're actually representing. And you know, we talk about that in the class right before this one. If any of you were in my rendering class, we did a lot of things in that class that were inaccurate. Because the reality is, a lot of it you're not going to see, right? So don't model it. Anyway, moving on with that, away from my sidebar, the next thing we need to focus on is like some kind of unique panel inside. And I'm going to go with a very simple one first. But simple version is, we're going to take each of these surfaces, right? These ones that are inside. Kind of see where I'm going with this so far? We're going to reduce the size of it. You can do that a few different ways. You could do it using scale. You could do it using ConstructDomain. The simplest version is to probably just say transform, affine, and scale. Plug those in. We're going to find the center point, right, using surface, area, and plug that in there. You see that it's making it a little bit smaller already. But we just put a slider on there, 0 to 1.00. You just bump that up. And you can turn the old stuff off, and you get something with like a floating panel inside. Okay? Not that hard, right? If you look at it, and this is probably one of the more complex things that we've developed, but it's one of our simplest definitions. That's all we did in order to get that. And by now, I know if I showed you this on day one, you'd be like, oh my god, it's so much. But right now, this looks like nothing to you. Each one of you could probably sit down and do this in 5-10 minutes, right? More or less?
More or less.
Right.
Maybe 1 minute.
Yeah, well, maybe. So here's another thing that I wanted to show you. So if your surface, right, and let's say you're designing this thing and something doesn't quite jive, right? I want you to get into the practice of not thinking of your definitions as complete thoughts. Sometimes they're complete thoughts, but I might want to change something that requires me to modify this systemically back in the beginning, okay? And some of you have been practicing this. Not all of you have encountered it yet, but let's say let's say I'm your design critic and I say, this isn't believable. Your handrails, most guardrails and handrails don't go all the way to the ground. They're kind of lifted a few inches off, and that's for a very good reason, for drainage. So water can run off the side of the bridge and won't get trapped on it, because with this one, water would get trapped, right? That's a reasonable thing that a design professor might say, if they care. But anyway, you need to change that now. The simplest version is, if I take this extrusion, I need to lift it up off the ground. Well, I built it directly off the curve, and then I just extruded it up. But the cool thing is, we can just insert some other modification into this area, right? I want you to practice doing this. Just create yourself a little workspace and say, I need to change something here that's going to lift the entire base surface up before I subdivide it. So that way I just, you know, the whole system's going to work just fine. And so how do you do that? Well, oh, I don't have any, yeah, well, anyway. So we just go to ConstructDomain squared, So I'll go back down to ConstructDomain squared. I'm going to go back up to surface and utility. I'm going to use isotrim. Plug that in here, plug this in here. These, again, you could either use it as a magnitude or you could use it as a percentage value. I tend to like percentage values very frequently because in most schematic, like early design applications, the exact dimension doesn't matter that much. So 0 to 1.00 is what I'm going to do, not 100. Whoops. Gonna need 4 of these. Oops. 1, 2, 3, 4. Umax, Vmax. Okay. So where's the surface, right? Well, the surface isn't going to do anything because it's really tiny down there because I haven't reparametrized it. So let me reparametrize that. Okay. So if I want to lift this surface off the ground, I just need to figure out whether or not it's in the U or V direction. So I'll just pull my Vmin. Where does that go? Oh, that's coming from the other side. That's not it. So it's got to be Umin. And so I just pull Umin up to a value that's a little bit, sitting a few inches off the ground of the bridge. And then all I need to do is just replace these connections. So I'll just, well, let me give you a tip here, right? This one's probably not going to crash, but once you start inserting things like this, there could be a major discrepancy between the surfaces that are plugged in here if I only replace one surface connection at a time. So a nifty trick is when you're inserting things, it's best practice to lock your solver, right? If you right-click in the workspace, I want you all to look at that right now. Right-click in the workspace, and you click on this button right here called Lock Solver. What that's going to do is stop Grasshopper from calculating until you've plugged in all the connections you intend to plug in. Okay, so that way, when I plug in Subsurf down here, right, that's my new surface, it's not trying to compute a subdivision on the new surface, but then reapply the actual application of that subdivision onto the old surface. Does that make any sense? So anyway, you just need to reconnect both of those and then turn off Lock Solver and it'll run again. Okay, so you didn't quite see what happened when I turned it off, but let's turn the old definition off. And so this is what we did. We raised what used to be on the ground. We very simply just added like 3 components and then we were able to lift it off the ground like that. Okay, so that's actually a pretty powerful thing, is to get in the practice of inserting. This is all we added. Get in the practice of inserting little things in order to accomplish what your design goal is. What questions do you have? Okay, so let me just throw in, how are we doing on time on this one? It's getting a little long, but I do just want to throw in a little something about other types of geometry. If you happen to not want a pipe geometry, something like this, and you want to build it off of the curves in a different way, I'll hide those for now, and I'll hide that for now. What you can do is isolate those curves. So let me just kind of plug this out here this way for a moment. Once you've deconstructed it, the cool thing is they come in packages of 4. Okay, so you can list item and grab a certain part of that package, which is set list item, and I'm going to plug this in here and slider from 0 to 3. Whether or not it's 0 or 1, so 0 would only grab the verticals on the left side of my panels. That's significant because if I go back through that exercise, copy paste, and I grab the individual faces and flatten that list, I can grab just one particular face. There are more clever ways of doing this, but if I change the direction that this is going to, say, the other side of where the first panel is, then I can do the same thing with this panel. I know it's getting a little crazy here, but do the same thing with that panel, but do it for the other original surface. I need to deconstruct first. I need to break this panel down, then put my edges in, and then change that to the other side. So you're going to need to hide all these, but these are the curves that you're going to want. This stuff gets all hidden, and there you have just your vertical, there you get just your verticals. Okay, so that's all list control. I've done nothing that you haven't seen before. All I did was change how my list item was being isolated, and then I grabbed just the edges that are applicable. And then from there, I can use that to do a few things. I can extrude it. I can create flat panels. I can create louvers, whatever the system is that I want to use. And I'll very quickly just throw one in just as a, in the interest of just showing you a different kind of geometry. But if I just use unit Y and then I use unit X, you'll see. So I just need to go to transform. I'm going to, I'm going to extrude it. So I'm going to extrude. I'm going to extrude all of these, so I need to merge them. I know I'm throwing a lot at you guys, but you're going to have this and you can use it all you want. But let's go to set list and merge that one with that one. Flatten that guy. Oh, that didn't merge. That's weird. Anyway, we'll flatten that list. So you just plug them all in, you plug in which direction they're going to go, and then they'll create something like that. Okay, so whether or not that's going to be a very long one, we'll say 0 to 1.00, we'll shorten that up, something kind of like that. And then you just do the same thing, you'll extrude again, and do it in the other direction. You might want to, you're probably going to want to do this with surface normals, but that's the idea of what we're doing here. We're just going to create more unique subdivisions and stuff in order to create more complex geometry for our bridge edge. Is that making sense? So we have the scale panels that could fit inside of these sort of, soldier columns, whatever the condition is. You guys can accomplish it with ConstructDomain and DivideDomain squared. Pretty much. Questions? I know that ran really long, I'm sorry, but there were a lot of very important ideas that I thought were very important to get into one video. Okay?